Hey everyone, with Twitter I did a poll of what I should do for this upcoming week, and it was decided on we're going to merge both hitting and pitching data from college baseball from 2013 to 2019 together into one giant data frame. But I also will add some plots, and I will show you some basic plots with this. So again, I'm going to run through. I highly recommend that you watch Scraping Hyperlink Data with Baseball Reference in R, my previous video. Please, please, please watch that video first before we continue on in this video. Please watch Scraping Hyperlink Data with Baseball Reference before you get in this code. It will definitely help you understand this code a little bit better. So I'm going to give a quick little rundown of the last video's code, so on and so forth, and kind of give you a little explainer. Again, it's on my GitHub page, what you need in terms of code, but both of this for hitting and pitching data will be shown, and I'll just kind of go through each one really quickly because it's essentially the same thing. Again, please watch the last video. It will help you explain a lot and help you go step by step. But if you haven't installed these packages, please do. To install these packages, please remove the comment, which is the hashtag right there, and you'll just, click on it and remove it, and then install by either highlighting the line or clicking the run command. Then you call these into the library, and that gets our 4 plots. Again, RVest for scraping, plier to get our list into a data frame, tidyverse for a multitude of things, and then plotly to help visualize plots. So again, we'll start with years. The baseball reference goes from 2013 to 2019, so we'll get all those there. And then the URL that we'll grab is the Baseball Reference Registered League Group NCAA year, and then this is where when we assign the years for that, that's where we'll get it from, all league batting, and it'll go through each of those years to get those URLs. Then we'll scrape hyperlinks. Again, this will be way better explained in my last video of hyperlink data, but it's pulling the XPath and then pulling the hyperlinks of each page from these URLs, so on and so forth. Then we get to assign the year and the conference, and again we get to assign the year, so on and so forth. Then we'll again do an LDPly through dplyr to get into a data frame, and then we'll get all those URL IDs and put it into all league batting to get that specific conference batting data. Then we'll get the HTML nodes, again explained better in the last video. Basically what it does, it pulls those conferences and gets the correct conference, so on and so forth. Then we'll create another list that will pull all the league batting data from each conference, so each individual team, and then go through and get each year, or correctly assign each year and then each conference. And again, system sleep is important here because a lot of code is to be ran. It's every team from every conference from 2013 to 2019. System sleep helps you efficiently run the code. That way, if it takes a long time to run your code, it doesn't time out. That's where system sleep comes in to kind of efficiently run that process, if you will. Then we will again convert that to a data frame. Then we'll do a coalesce. When we did pull it, again I'll show it below in the pitching data, where we take each column from these divisions columns and select the team name that's listed in there and replace that NA in the team column. Then we'll check NAs, remove unnecessary columns, so on and so forth. Pull the division CSV again. This is on my GitHub. Then conference data, merge those together by conference and year. Get all the rows possible, check for NAs, and then remove league totals. So here we go. With pitching data. Again, call those libraries if you haven't already. If you have, you don't have to worry about it. and then scrape the URLs of each year again, but this time instead of all league batting, we do all league pitching. Then we'll do a list, again, XPath, href to pull that hyperlink data. Then we'll do an ldply, again, all league pitching, and then we'll pull the correct conference with the metaspan plus span. Then we'll do, again, conference table, getting all the URL IDs and getting all the league pitching data, again, with the system sleep to help efficiently run your code. I cannot say that enough. It will time out if you don't put the system sleep on there. All right, so we're going to start on this line. Again, the ldply from the plier package converts that list and makes a big data frame out of it. And then we will mutate those columns. So run that. Then we'll say view NCAA pitching comps. Run that. And we can see that, you know, there's teams that appear here in the Coastal Division, but it's NA here. And a quick way to do that is using the coalesce function. First using the mutate in the dplyr package, and then the coalesce, which is a SQL function, which essentially grabs those values that aren't NA in other columns and replaces the NA values in this case the team column. So we'll run that, gets all of that, and then we'll check if there's any NAs. There are not. Then we'll go back into it and see, you know, what columns are necessary. So we don't really need that because that's all NA, and then we don't need the last 5. So we'll just get rid of those. Then we'll read the CSV of divisions to correctly get Division 1 and Division 2. And then column names, change the columns so that way you can correctly merge. Create a merge to get the divisions there. Then we'll check if there's any NAs in division. There is not. And then going forward, there's a league totals for every table that was scraped. So a quick and dirty way to get rid of that is NCAA pitch count data, do a grepel, but the exclamation point kind of says don't keep those rows that have league totals. Again, that comma in front, or the code written in front of that comma, means do this to all the rows. So remove the rows that contain league totals in the column NCAA pitch count data. Remove that. And now we can get started with merging the pitching data and the hitting data. So we'll say merge both data together. And we'll call it NCAA hit pitch data. Again, do another merge, just like above, NCAA conf data, and then y equals NCAA pitch conf data by, we'll do a combine element, team, year, and looks like I hit a weird key, but that's alright. We will find that insert button. So sometimes you may run across this, good point, bring it up, but that flashing cursor, to get rid of that, you just find the insert key and you will get rid of it, just like that. So by combine team and year, and then again we want all the rows possible, so all x equals true. We'll do that. Then we'll view it. View NCAA hit pitch data. Go through it. And again, this is where I'll show you, sometimes I'll say strikeout X, BB X, walks, home runs X. X refers to the hitting data. Again, that's what I assigned it as. Since it's NCAA conf data, that's the hitting data. It will be referred to as X. And then on the Y side, home runs, walks, this is from the pitching side. So getting that as a reference. And going back into it, we can see that some columns contain all NAs, like games finished, complete games, intentional walks. And here's a quick and easy way to remove that. So we'll say remove all NA columns. Can't spell columns. That's okay. And again, you can do it with a filter, or for me, I like doing a subset in this case. So subset NCAA hit pitch data. So we'll keep that data frame. We'll subset it by selecting, and we'll say a negative combine. That means we don't want to keep these columns. IBBX. And in this case, since you already called the NCAA hit pitch data, you don't have to put the column names in quotes. You can just leave it as is, IBBY, games finished, and complete games. Get rid of that. That removes those 4 columns. Now we can create data frames for D1 and D2. So we can say D1 data. In this case, we can do a filter. NCAA, again, NCAA hit pitch data. And since they both have a division X and a division Y, I'll do division X equals 1. Run that. We can copy and paste the above. Instead say D2 data, where it's division 2. And then this is where we can check if there's any NAs. So we'll say check NAs. We'll do a sum dot is NA D1 data. Copy and paste that to get D2 data as well. Pretty simply here. And you can see that there are 156 observations where something is NA, and again, we removed those all NA columns, so essentially that just means a team may have missing data, and we'll go through and see exactly what it is. So view D2 data. And I mean, there's a lot of ways of doing this. What I'll normally do is just, sort by a column and then scroll all the way down. And you can see that Holy Names, Queen's University of Charlotte, and Spring Hill don't have any data for these given years. So, quick and easy way to get rid of that so we can plot is by doing D2 data equals NA.omit. We remove all the NAs from the D2 data. And that should remove it. Let's go all the way at the end. The last observation is Lincoln University, and it has data. So we are good. And again, we can do sum.is.na as well. See, there's no more NAs. Now we can move on and create some plots. So we can see what correlates to what in terms of linear regression. Through the Tidyverse package, there's a package called ggplot, which is extremely useful for plotting anything and everything, really. And from the earlier call, we called another package called Plotly, which I find useful when I want to zoom in data or have certain tooltips available when I hover over the text, and I'll show you here shortly. So we're going to do a basic ggplot with regression, obviously. So we'll do a ggplot. That's our call right here. And we'll say data equals, let's start with D1 data. And then AES, which is short for aesthetic. X, we'll say, let's do batting average. I know I'm controversial starting with batting average, but we'll start with batting average just to make it applicable to everyone. And then we'll do win-loss percentage, which is denoted as W period L period. And then within it as well, we'll do two different labels. The first label will be team. Then the second label will be year. And we'll continue on. So kind of like dplyr, how the piping operator continues on the code, ggplot uses the plus to continue on the code. Then we want to indicate we want point, so we'll do geom point. Again, there's a lot of geoms in ggplot. You can feel free to look through all of them. We want to have a geom point in here. Then, since it's a regression, we'll do a stat smooth, which is just a smoothing of the data. And we'll do a Y label, because we don't want Y period L period for our plot, so we'll do winning percentage. And then another plus. And we're going to do an annotate, because we want the R-squared value of our linear regression to see how strong or weak the relationship is. Again, linear regression goes from 0 to 1 in terms of R-squared. It takes the two given variables, batting average and wins and losses, and makes a comparison between each team's batting average and winning percentage, and then computes an R-squared value between 0 and 1, determining the relationship. It can be negative, so a basic example would be like, if your team allows more runs, you're not expected to win more games. It's a very simple example, but so on and so forth. So we'll do an annotate. We'll do text to indicate text. And then, since batting average is between 0 and 1, we'll denote X as, we'll say 280. And then Y equals 1. Then our label, we'll do a paste 0. And this is where we'll type in R squared equals, in parentheses. Again, I hit that button. That's all right. Comma. We'll do a round, because we want to do a correlation. Round, core, to figure out the R squared value. We'll say X equals, and this is where we'll say D1 data, and then the $sign to indicate what column we want to refer to, which is batting average, comma, Y equals D1 data, win period, loss period. And then we want 3 decimal points. And then we'll put this in an operator known as P. So we'll run all that. And it'll be stored in P until we call it in the ggplotly. So we'll type in ggplotly, and we'll just simply do P. And I'll tell you the formula. I'll drag this out a little bit so you can see it a little bit better. But the R squared is a relatively high value at 0.614, so there is a pretty good relationship between high batting average and winning percentage. And you can see right here, this is where ggplotly comes in with the tooltips in terms of when I called the two labels of team and year. You can see that, University of New Mexico in 2015, so on and so forth. New Mexico State in the past year had a team batting average of 356, and they won 69.1% of their games in 2019. You can continue to go on, so we can say, instead of batting average, let's look at ERA. And again, we'll replace that in here. But since ERA is scaled a little bit differently, we'll make this 10, if you will. And we'll run both of these values. Give it a minute to publish. And so, yeah, it's a negative value. So that essentially means there's a very strong relationship between ERA and winning percentage. It essentially means the more earned runs you give up, the less games you're going to win. And you can see pretty clearly. Oregon State won 90% of their games with a 1.93 team ERA. You can see a lot of these teams up here at the top are very good. University of Illinois, in 2015, won 83.3% of their games with a team ERA of 2.55, so on and so forth. You will obviously see a lot of Power 5 teams in here, but the gist of the story. And the cool thing with Plotly is you can zoom in, so you can zoom in and see the zooms, or if you want to focus in on a certain area of points, you can, and it'll focus in on those given areas of points. So a lot of cool things you can do there. Feel free to go into D2 data, or the overall data as a whole, and go through all the variables and see what are strong relationships, what are weak relationships to winning percentage, so on and so forth, or with even variables themselves like ERAs to RA9, or strikeouts to WHIP, so on and so forth. But feel free to like and subscribe. More videos coming out once a week, and to help others learn how to code in R, especially the baseball data. I really want to help others get into learning R, a great resource to use and to analyze and further their education in using data to make quality decisions.